Now I just disconnected the ground just for demonstration purposes. You may come across the situation where you're in a house, an apartment, or a building that you're renting or own, and you happen to have a receptacle that has the 3-prong outlet and it's not grounded for whatever reason, either the shielding, which some older buildings have, which is called armor clad or armor clad AC or BX cabling, which has that steel or aluminum mesh, which also acts as a ground too as well. That's why I say about grounding and how important it is for computers. You can still use that type of wiring in your building. Just make sure that if you use an armor clad or BX cabling system, that all your points in the electrical system are properly grounded and each connection is super tight, so it can't be taken loose at any given point, or it doesn't come loose by itself because it wasn't tightened down properly. So AC or armor clad wiring, which is the old BX tubing. Some may have the little ground sheathing that you just wrap around it to use it for continuity purposes, but some don't have that little thin wire that you wrap around the steel or armor clad mesh, which acts as a ground. But if you don't, and for some reason it won't ground, most likely the old BX or the old armor clad is rusted, and you may have a receptacle in this case. Or if you have a home that has Romex wiring, or a building that has Romex wiring that doesn't have a ground, it's going to open up as well with an open ground, which is no good for computers either, because if there's a short circuit in the system, it needs something to go back. It needs something to short back to ground, either the hot or the neutral side, if the outlet is happen to be reversed. And if without the ground, there's no way to send back that short circuit to the service panel of the electrical circuit to trip it. So it will prevent any further current to that outlet, which will cause serious problems like fires in some cases. That's why I say grounding is important in all electrical circuits, whether if you make your own circuits for your electronic hobby activities, or cases with computers and home theater systems that require good electrical wiring at the outlet or in the circuit itself. So if you see an outlet that's not properly grounded, like I said, call an electrician immediately if you plan on using that outlet for ground, or just have them to replace it with a 2-prong electrical outlet until that grounding situation is taken care of. Most likely, if you're selling a house, I don't know the intricacies of it to know, but they're gonna want to have that problem addressed as soon as possible, so that it won't be a responsibility or a major burden on the next owner that will own the house or building for that matter. And to test for an open ground with the multimeter, let's just say if you don't happen to have this handy electrical outlet tester, you can use, again, the same multimeter. You set it to AC. It should say so on the multimeter, volt AC. The next switch is for DC, but since we're working on AC circuits now, which is the power that's coming from the electrical panel to the wall receptacle in your house or condo or place of business or an apartment, that's always going to be set to AC, and it should be at 120 volts maximum. It shouldn't be no 220 volt going through this, which in some cases, a lot of circuits don't switch automatically, like some computers, some home theaters, some monitors, some printers don't switch automatically. And then you wonder why, like I said, your motherboard fried itself because it was plugged into an electrical outlet and it wasn't properly grounded or wired properly. And another thing I didn't mention in the last video, some surge protectors and some battery UPS backups have a built-in sort of like tester, which would tell you that your wiring is wired correctly or it's wired incorrectly, and it will sometimes light up with it a amber or a red light saying fault or ground fault somewhere, or the ground will light green which means a good ground. But the test for open ground in a receptacle, if you don't have this multimeter testing and you want to test it with the multimeter, you just simply do this. Let me just lay this convenience receptacle down. Now I've reversed the polarity in the outlet. So what you do is, this is understood to be the hot side. So you take your hot side of the multimeter, you plug one probe into one of the hot, and you test the screw, which is normally the ground, which grounds the box, and the box is grounded from the AC, and you just test it, and your multimeter should read 0. I don't know why this is reading 32 volts, but that's not good. It should go to 0. Let's try the neutral side. Maybe because this outlet tester is in the way. That's reading 59 volts, which is not good as well. Let me unplug this multimeter and just to test it out for you. Hold on for a second. Okay, let's unplug that for a minute. It comes in at about 3 volts. Maybe because there's a battery that's running. I don't know, but it should equal less than let's say 10 volts. That's on the neutral side. Now we're going to plug the probe back into the hot side of the outlet again, and then test the ground. I don't know why it's coming in at 36, but it's understood that this circuit is open. The ground is open as indicated on the receptacle tester here. So if you're not getting a full 120 volts on each side of the rail or each side of the outlet, then you know it's open, because again, you need the ground for least path of resistance back to the service panel in order for it to trip. It can also trip on the neutral side. Some older boxes may trip on the neutral side if it's set up that way. Now, the test for a full 120 volts on an open ground circuit, you just take one end of the probe, which is your positive side or negative, it doesn't matter with AC. You connect it to this side and you connect this one back to the negative. It should get about 120 volts, which mine reads on the multimeter as 120.4 volts. And if same thing, if it was to reverse it, it should still be 120 volts. Now, if you do neutral side, which is the longer blade to ground, it should be about 3 volts. This will also tell you that this outlet is properly grounded, because I've now reversed the hot and neutral side of this convenience receptacle, and it's reading less than 10 volts, or it should read 0. And if you go hot to ground with an open ground circuit, it should be less than 50 volts, or should then equal to 0, because there's no path of resistance back to ground if something was to short out at the receptacle. And it should trip the breaker at your circuit breaker or pop the fuse. See, it's reading less than 20 volts now. I have this probe to the ground or to the ground screw, which is another way to test for grounding. You take, I know I'm repeating myself, but the point I'm trying to make is, if you want to test for open ground in your household or in your place of business, these two tools are very essential to test for bad electrical wiring or open circuits in your household. So I would invest some money into it, not a whole lot, but this will save you a lot of time and aggravation down the road if something drastic was to happen to your computer or home theater system. So that's why the point of me making this video is to educate you folks on the importance of properly grounded electrical sockets in your household or a place of business is important for safety and longevity of your computer. This concludes this public service announcement and important how-to video. If you have any questions or comments, please leave it in the section below. Until then, take care and be safe. Thank you for watching this video.